Ever wonder how your refrigerator keeps your food fresh? It's all thanks to a small black dome-shaped device inside the compressor. This is the heart of your fridge, quietly working to keep everything cold. The compressor acts like a pump for a special gas called refrigerant. Its main job? Squeeze the cool, low-pressure gas into a hot, high-pressure vapor, the first step in the cooling cycle. By compressing the refrigerant, it sets the stage for the gas to release heat and become a cold liquid, ready to absorb warmth from inside your fridge. It's a marvel of engineering, running efficiently for years, cycling on and off as needed. The compressor is the biggest energy user in your fridge, but a well-designed one keeps your food fresh and your energy bills low. So next time you grab a cold drink, remember the humble compressor, the unsung hero making modern life possible. It's the reason your lettuce stays crisp and your ice cream frozen. This small, overlooked component is the cornerstone of modern convenience. Inside that sealed black shell is a world of moving parts working in harmony. The electric motor is the muscle, made of a stator and a spinning rotor. Electricity flows through copper windings, creating a magnetic field that spins the rotor. Most fridges use a piston and cylinder setup like a tiny car engine to compress the refrigerant. As the piston moves, it draws in cool gas and squeezes it into a high-pressure vapor. Lubrication is vital. Refrigeration oil in the sump keeps everything running smoothly and quietly. All these parts are housed in a sturdy, hermetically sealed steel casing, keeping the refrigerant and oil safely inside. The casing also muffles sound so you only hear a gentle hum. Every component from motor to casing is built for years of reliable service. Building a compressor starts with carefully chosen materials. Steel forms the tough outer shell, shaped to withstand decades of high pressure. Copper, prized for conductivity, is used in the motor windings and connecting tubes. Aluminum often forms the lightweight, efficient rotor inside the motor. Die casting combines steel and aluminum for a responsive, energy-saving rotor. Specialized plastics and composites are used for valve plates and electrical parts. The oil is a synthetic lubricant, designed to work with refrigerant and handle extreme temperatures. Each material is selected for strength, efficiency, and long life. Together they create a compressor built to last. The motor's creation is a blend of automation and precision. Thin steel laminations are stacked to form the stator core, then wound with copper wire by robotic machines. The rotor, made from steel laminations, is die-cast with aluminum to form a squirrel cage structure. A central shaft is pressed into the rotor, ready to connect to the compressor's crankshaft. The stator is fitted into the steel casing and the rotor is inserted with a precise air gap for efficiency. Precision bearings ensure smooth, long-lasting rotation. Electrical connections are made through hermetically sealed pins, keeping the system airtight. These connections allow power in, but keep refrigerant sealed inside. Once tested, the motor is ready to drive the compression mechanism. It's now a compact, powerful, electromechanical heart. With the motor in place, it's time to assemble the parts that compress the refrigerant. The crankshaft attaches to the motor's rotor, converting spinning motion into the piston's up and down movement. The connecting rod links crankshaft and piston, which slides inside a smooth, precisely bored cylinder. The cylinder block is bolted to the motor housing, ensuring perfect alignment. At the top, a valve plate with intake and exhaust valves controls the flow of refrigerant gas. These simple steel reeds open and close automatically with pressure changes. The assembly is tested for smooth operation and precise clearances. Technicians check for noise and proper movement. This careful assembly ensures the compressor's mechanical heart will run reliably for years. Once assembled, the compressor is sealed inside its steel shell. The top half of the dome-shaped casing is lowered over the internal parts, meeting the bottom half at a seam. Automated welding robots fuse the seam with a high-temperature arc, creating a seamless, hermetic seal. This airtight weld is crucial. It keeps refrigerant and oil safely inside for the compressor's entire life. Even a tiny leak would ruin the fridge's cooling ability. After welding, the compressor is often heated in an oven to relieve internal stresses, making the casing even stronger. The result is the familiar black dome, robust and ready for action. This process ensures the compressor can handle years of pressure and temperature changes. The sealed unit is now a durable powerhouse. It's ready for the next stage: rigorous testing. Every compressor faces a series of tough tests before leaving the factory. First, a leak test. The unit is filled with tracer gas and checked for even the tiniest escape. Next, a pressure test pushes the casing beyond normal limits to ensure strength and safety. Electrical systems are tested with high voltage to check insulation and prevent shorts. Performance testing simulates real fridge conditions, monitoring power use, pressure, and temperature. Data is compared to strict standards for efficiency and reliability. Noise and vibration tests ensure the compressor runs quietly and smoothly. Only compressors that pass every test are approved for shipping. Quality control is relentless. No flaws allowed. The result, a compressor ready for years of flawless service. After passing all tests, the compressor is cleaned, painted, and labeled. The black paint protects against rust and corrosion. Each unit gets a unique label with model, serial number, and specs, vital for installation and service. Compressors are packed in trays, stacked on pallets, and shrink-wrapped for safe transport. Forklifts move them to the shipping warehouse, ready for delivery worldwide. At the refrigerator factory, compressors are unpacked and installed on the assembly line. Copper tubes are brazed to connect the cooling system, and electrical connections are made. The system is charged with refrigerant and oil. The compressor is now ready to keep your food cool in its new home. For years, compressors ran at full power or not at all, simple but not efficient. Now, smart variable speed compressors are changing the game. These inverter compressors adjust speed in real time, using only the energy needed. They ramp up for quick cooling, then run low and steady to maintain temperature. This cuts energy use by up to 40%, saving money and reducing environmental impact. They're quieter, last longer, and can even connect to sensors or the internet. Some learn your habits, optimizing performance and alerting you to problems. The compressor is evolving from a simple pump to the intelligent heart of a smart, sustainable home. The future of cooling is efficient, quiet, and connected,